In this video, we'll be looking at the properties of logarithmic expressions, specifically the product rule. Now, when looking at the product rule, you have to remember that we're technically talking about exponential functions that have been converted into logarithmic expressions. So when we're looking at this expression right here, you have to recall that b to the m times b to the n, what you're going to do is you're going to add the two exponents together when combining. Again, it's something like 3 to the power of 2 times 3 to the power of 3. You can rewrite it as 3 times 3 times 3 times 3 times 3. And in reality, that's 3 to the 5th, which again behaves as though you're just doing 3 to the 2 plus 3. So this is the rule for exponential functions. Well, let's talk about the rule for logarithmic. For us to do this, we're going to go ahead and let b, m, and n be positive, real numbers, such that specifically b does not equal to 1. With all this being stated, the rule is log base b of m times n inside the log function is equal to log base b of m plus log base b of n. Now, it's important for us to remember that every log function is really just the inverse of a exponential function. So when we're talking about logs and exponentials in this particular case, we have to realize that if I'm multiplying the exterior of two exponential functions, then that inversely compares to multiplying the inside of one log function. Again, multiplying the outside of two exponentials becomes multiplying the inside of a single log, while as the addition inside of a single exponential becomes the addition of two separate logs. So if we can remember this expression, then hopefully, again, notice all the bases are the same and all the bases are the same, that this expression will allow us to inversely compare to this one. Multiplication on the outside changes to be multiplication on the inside, addition on the inside changes to addition on the outside. So, with that being said, let's look at a couple of examples for this. So log base, say, 6 of 77. So in this case, you don't see any actual multiplications occurring, but what you can argue is that if I'm asked to expand this, even if there's no actual multiplication shown here, we can still go ahead and rewrite this as 7 times 11 inside the log function, because that's what 77 really is. This then also will equal to log base 6 of 7 plus, again, notice that the multiplication here will change to an addition, and I'm going to have to write a second log function to express the other piece. So this shows us that this expanded becomes this. Now, in some cases, that doesn't seem like it's going to help very much. For this case, it won't. Log base 6 of 7 is not something that you know, and log base 6 of 11 is not something that you know. What if this was 66, however? If this was 66, log base 6 of 66, well, then I could not only expand this function like the problem asks me to, but I can also reduce it. Eliminate some of the logarithmic expression, because log base 6 of 6, as we talked about in a previous video, is simply just 1. What power of 6 gives you 6? It's 1 plus log base 6 of 11. Now sure, there's still a log function in this expression, but at least it's not as much of a log expression. It's a little bit easier to deal with. So that's the first example. The second example we can look at in terms of, again, this product rule is something that looks like this, log of 100x. This is another case where it should be apparent to look at and say, well, wait a second, what's the base? Because there's no base written, the base is 10, which means that I can go ahead and rewrite this as log, again, base 10, I'm not going to write it as, well, let's see here, there's 100 times x, so if I can do 100 plus log of x. Now, sure, again, this is really nice for the sake that my log of a number plus the log of a variable have been separated. This might actually help later on when solving equations. What is also important is that, just like we did in the last example, that log base 10 of 100 can be simplified. Every time that you expand these problems, you really should ask yourself, can this simplify in any way? Well, log base 10 of 100, what power of 10 gives me 100? And that power is 2. So 2 plus log of x. And again, if I was attempting to solve something like this, well, this would be a heck of a lot easier to manipulate to solve than, say, this expression back here, or even this expression back here. So that's your simplified version utilizing the product rule, making sure that, again, anytime that you're multiplying on the inside of a log, it can be separated into the addition of two separate logs. And the base here, as long as it's not 1, this particular rule will apply.